I just got this voice.
Hey everybody, there, perfect time to pause Spotify, close those ads down. Happy Wednesday, right? It is Wednesday, isn't it? Let's check the calendar. Yes, it is in fact Wednesday. Oh, that's so trippy, I like that view. Alright, sorry to miss you guys last week. Totally just, misestimated how much free time I thought I'd have sitting at a hospital and in the hotel. And turns out you're busier than just sitting around, so apologies, thanks for being flexible. I did bump out the Project 2 due date, so for the 6 of you who got it in on time, thank you, congratulations. I hope you didn't do anything terrible to get it in on time. It was kind of late notice that I bumped it out, but I asked around on Discord and not a lot of people had it done. And there was stuff I wanted to talk about, and we'll go over unit testing again, so hopefully you're okay with it getting pushed out. You didn't do anything heroic like that. So I think one person had emailed me and I said no, and then I just emailed them back and said, I'm sorry, I just changed my mind. I don't know, like if it's just one person says they're having trouble, then I'm not super inclined to push the whole thing out. But a couple people say they're having some trouble, then I can go for it. So that'll happen next week. I did update the syllabus as well. That's out here. Yeah, I don't need the Word version, do I? Close that one. I'll make sure it's current here in Desire to Learn. Here we go. So I just updated it. It's just like replaced on top here. So let's see. Page 8. So we just bumped everything a week here to this missed week. Apologies again. We'll finish up chapter 7 tonight, and then next week we'll pick it up with arrays and vectors and start project 3. So I did take out a project. So there will only be 5 individual projects instead. Yeah, I think that'll be okay. I mean, this first one wasn't really a big project at all. It was like, hey, can you get something in GitHub? So really just the 4 individual projects and then the final project here are going to make up the bulk of your grade. And then once we finish up chapter 7, we'll have the chapter 7 quiz. I think you guys were doing pretty good getting the quizzes in. I haven't gone over the answers to them yet. So if you had some sort of trouble or forgot them, or I didn't make it clear enough in Desire to Learn that they were due, I'll still take them late if you want to. We'll probably be reviewing them when it comes time for midterm prep. We'll do that 2 more weeks. We'll talk about pointers, and then we'll do some midterm prep. Again, the midterm will be like a take-home style midterm, but it'll be timed so that everyone has the same amount of time from start to finish to do it. So that way, some people I know are busy during the day and might work or have other obligations. I don't want to give some people all day long to do it, and the other people only get their 4 hours a night to get it done. So the goal is going to be maybe about a 2-hour test or so, and then we'll work on chapter 11. I don't think we'll need all 4 hours for chapter 11, so we'll kind of gauge that and see. We'll probably end chapter 11 early to give you time to take that midterm. I don't want you to take more than too much time working on that, but it is a college class, so the expectation there is you're doing 2 hours of homework for every credit per week. So at a 4-credit class, it's 4 hours of in-class stuff per week plus 8 hours of homework, reading, assignments, whatever stuff on top of that. So a 4-credit class is a little bit intense for sure. So we just took out that review week that was down here. Everything else just bumped itself down one. I'll still assign the final project this week, and we'll use some exceptions in it. So you can get some of the stuff done based on what we've done in here when we get to the final project. We'll add in the exceptions when we go. And then someone else had kindly pointed out that I did not even add a rubric. So I'm sorry, I've just done totally missed that one here. So let's go add a rubric for our projects here. That's in assignments. And you can see how you're going to get your points here for this project. And we can talk about it again real quick and hopefully clear up any questions you guys might have. So that was project number 2. Let's edit that. All right. So we're building a little retirement calculator using classes. So it sets and gets for our classes. They're not super interesting, but they're going to be containing that data. Right? That idea that a class is a noun that represents something, and all of its attributes, all the data about itself are its attributes, its instance attributes. And every instance of that class can have different values. So you might have a bank savings account at this bank, and you might have a bank savings account at another bank. They both do the same thing because they're both savings accounts, right? You can add money, you can withdraw money, and you hopefully will get some sort of fixed annual rate of return, some interest rate. Is that 3 things? I don't know where my fingers are on the camera, right? And then we're going to write unit tests to make sure that the functions do what they're supposed to do, right? Any code that's worth writing is worth testing, so we're going to test it. We're going to have money in your pocket, which is essentially the same thing, but there's no rate of return, right? When you have cash in your pocket, it just sits there. Sometimes it burns a hole in your pocket. Maybe we'll say that has a negative. No, we're not going to take money away. But and then we'll have a market money, some sort of investment account that is totally made up, just a weird approximation, that will be a 4% variable rate of return that will get plus or minus 6% every time we go to apply using random. So we'll pick a random number, right, between +6 and -6, right, from -6 to +6, and then apply that, right, add it, or subtract. I guess if you're adding a negative, it's just the same as subtracting, to that 4% to see. Sometimes your money increases, sometimes it decreases. And I know that's not the actual variance that the real market was. We're just sort of making it up as we go. And I'll show you how to unit test that. Someone had a question about it, and that was supposed to be until last week. We'll talk about unit testing now, so I'll take out that note. I don't know, let's see, lecture on 10.7, or how to test this. There's a cool thing we can do, and I'll show you how you can test something like that. Okay, and then you can add money to it and withdraw money. Again, just a weird, we're just saying there's a penalty for withdrawing money. It doesn't always exactly work like that, but we're just making it up, right? Typically, there's either you pay money when you add it, or you're paying when you withdraw, like a transaction fee. These sort of things, they're terrible, right? The people who are selling these products make the most money, right? That's why those companies are doing so well. But we're going to build a simulator, right? Using those classes here, right? For our bank savings, our money in our pocket, and our market money, we'll have a couple questions. We'll ask the user how old they are and what age they want to retire. That's going to tell us how many years we're going to run this little simulator and see what's going to happen, right? Then for each asset type, for our bank savings, for our money in our pocket, for our market money, find out what their current balance is. So like at age 33, like me, hopefully you've got some money in these accounts. At age 18, 19, 20, you know, hopefully you do, but it's possible you don't, and that's okay, right? Everyone, we got to start off somewhere. So we'll see what it is. Then every year until they retire, we're going to loop. We're going to apply that return on investment or the interest rate. So whatever this return is here, we're going to apply it. Whatever this fixed interest rate is, we're going to apply it. So you earn money for your bank savings, and you may or may not go up or down for the market money here. Then we're going to print the balance for each type and say, hey, did you want to save more money this year? Did you want to save it in your pocket? Did you want to save it in bank savings? Or did you want to save it in your market savings account? And once they reach retirement age, we're going to display the balance for each type. So this will happen every year, right, until they retire. Do you want to add more money? Do you want to add more money? Do you want to add more money? On and on and on and on. Once you reach retirement age, we're going to display the balances for each type. Again, you're kind of doing that as you go, so maybe that's not anything super special. Then we're going to generate a grand total and an adjustment per inflation, which is 1.02. Again, a fixed 2% interest rate assumption here is it goes up and down, and the way they count inflation is a little bit funny, but that's a story for economics or something. to the power of number of years. So however many years it was between now and their retirement, inflation is going to happen and reduce the spending power of their savings. Right? That idea, if you have $1 million now, 30 years from now, it won't buy you $1 million worth of goods, because inflation means that your goods are now more expensive. So we're going to adjust that for inflation to say, okay, well, you know, if you go from age 20 to age 70, right, for 50 years you work and you save money up, that money is going to be worth a whole lot less in 50 years. So that number that you're going to need is going to need to be a whole lot higher, right? And you can do some of that simple stuff like in Excel, which is really fancy, just to do some quick little math on it here. Right, so let's say this is 2020, 2021, 2022, and so on and so on. And we should be able to just make this go. Let's go 50 years, right? So if you're 20 now, right, one more. There you go, in 2070, right? And then we have, you know, savings, and then we have adjusted for inflation. And we probably, I guess we should have a simple little counter here. This is, I don't know, 1, 2, 3, on and on and on. So this way, this will make our inflation calculation a little easier. We don't have to do any arithmetic. Okay, so, oh, there's 51. Okay, so yeah, 50 years. That's right. All right, so if we had, we'll just, we'll shoot for the moon here, put $1 million in. And that's actually not very much savings, by the way, when it comes to retirement savings, if you're planning on living long at all. So adjusted for inflation is going to be this number divided by 1.02 to the power of, that's that one there, the year number. So 2% less here, right? At the end of the year, if inflation is 2%, our money will only be worth about $980,000 or so. And let's chunk that down, oops, less decimal places, right? And savings will be fixed, $1 million, right? We'll just pretend, right? We can ignore the growth thing here. We're just illustrating how much less your money is worth through inflation. So in 50 years, that $1 million is only worth about $371,000 worth here. So not a whole lot, right? That's a pretty large factor for inflation, right? So what is 1.02 to the 50th? Let's see, 1.02 to the 50th. That's a factor of 2.7 or so less worth. So, that's just kind of what we're doing here. So we're going to adjust it for inflation. Again, hopefully you're adding money every year, so you're kind of offsetting that, and hopefully your gains are better than the inflation rate. Okay, and just a fun little simulator. And fun might be a stretch there. Sorry. Let's see. So let me do a quick little poll here, because I found out I can do these in Twitch, and they're a lot of fun. So how do you feel about Project 2? Terrible. Haven't started. Okay. Have some of it done. Done, or good, mostly done, or already submitted. Okay, so there in Twitch chat, just take a look at the top of your chat and answer that poll for me. Let me know how you're feeling about Project 2. And I'm going to add a rubric, right, because we need to figure out how we earn points here. All right, these rubrics are kind of silly. Custom points, there we go. Oops, I should have done that first. That's all right. So again, answer that question in Twitch chat. I'll put together this rubric and we can go from there. This overall score thing is so silly. Like, I mean, can't you tell based on how many points you got? I don't know. Overall score, I don't know. I can't get rid of it for some reason. It won't let me delete them. Okay. So this, you'll get some points for the savings account class. Let's see, what are our results? What'd you guys say? So 3 people said okay, have some of it done. 1 person, terrible, hasn't started. And 1 person already submitted. Right, no goods, no mostly dones. So, no, that's all right. Only 5 people voting, but that's okay. We'll get there, right? We got 1 extra week on it, so hopefully that'll help out a little bit. All right, so your savings account class, right, with sets and gets and earning interest. That's 3 points for that one. Savings account unit tests. Let's do 2 more points for your unit tests on that one. Right, where you're testing your set, your get, and your earning interest. It's really hard to test set and get separately, so that's kind of like 1 test. Can you set it and is it there? And then another for earning interest, and you're also kind of using get as you go. And then we'll have the money in pocket class. That's only 1 point. It's not as interesting. Set and get. And then we'll have a unit test for money in pocket. And pocket class unit tests. That's probably just the 1 unit test, right? Can you set it and get the value back out? So there's 2 more points there. So we're at 7. We'll add the market money count with sets, gets, and variable interest. We'll make that one another 3 points. And then we'll do unit tests, market money, unit tests. We'll do another 3 points for that one, right? Because testing this variable interest rate is going to be a little bit tricky. So if you've already submitted and you want to change it, that's perfectly fine. You're welcome to update that. I know someone had asked me and I said skip it because we didn't talk about it. That was before I had changed my mind and decided to push out the due date. So hopefully you don't mind too much there. Okay, so then we got our unit tests. Then we've got the actual simulator itself. Right, so we have the simulator. So this has a couple different features, right? So it's the loops for every year until retirement. I will do 1 point for that one. And then the simulator allows for setting initial balance and adding funds to each account type every year. We'll do 2 points for that one. And then we'll add the simulator shows, I can't spell, come on, here we go, shows total balance and adjusted for inflation after the loop is done. And we'll do 2 points for that one. So it should be a total of 20 points there if I did that right. Let's see. 3, 5, 6, 7, 10, 13, 14, 15, 16, 17, 18. Oh no, only 18. Okay. You know what, that's okay. 18 points is good because the next project can be worth a little bit more. And usually they're going to kind of scale that sort of way. You know, should I do less? Let's do less. Let's do 15. Let's make this one only 2. Okay, now we're down to 15 points. I like it. So that'll be worth 15 points for that one. Any questions? Hey, Uncle Bill, thanks for hanging out. All right, questions about the project or the rubric itself, how you're going to earn points for following this project here? Again, sorry I didn't get that in sooner. I thought I did that. That's the weirdest thing. So I like to just do them while we talk about the project. Makes it easier, and then helps make sure I didn't miss anything. All right, questions? I'll pause for a minute. Yeah, unit tests. So we'll talk more about unit tests again. We're testing the methods of our class. So can you get a fixed interest rate? Right? Some sort of method like apply interest rate, that sort of thing. Does it change it by that fixed rate? And we're going to set that interest rate either by a function call or with a constructor that we'll talk about. Some way that you get to set this. So that should be fixed. It might be nice to have this as like a set interest rate, because banks do change that occasionally. I mean, that's what I've been told at least. They've been pretty low for a long time now, since the Federal Reserve has kept the interest rate so low. Interest rates have been pretty low. But we're testing those functions in bank savings. We're testing the set and get in money in your pocket. We're testing set and get withdrawal, including a fee, and this variable rate of return in market money. So we'll talk more about the unit tests in just a little bit. We'll do some more examples of unit testing. And if you don't have Visual Studio, you can do the poor man testing, where you are running it in main and actually checking the output, and if it doesn't equal printing out errors, couting errors. That's terrible, by the way, but that's okay. And, oh, I finally got the thing working the other night. I don't know if you guys are actually checking Discord or not, but I strongly encourage you to hop on Discord. It's !Discord if you need the link there in Twitch chat. You can ask questions just like in real class. Real class. And everyone hears your question and everyone hears the answer. Or reads your question and reads the answer, I guess, because we're not actually listening anywhere. So definitely encourage you to check that out. I had posted, that's where I was going with this. I had posted on there that, let me just open up Discord on my other computer here. I finally figured out that automated unit test thing that I was having so much trouble with. I just read the directions poorly. So I'll show you that again in a minute. And it's super cool. So every time we make a commit to our code, we get all the unit tests to run. Hey, thanks, Heather. Yeah, check out the Discord. Come hang out with us. Let's see. I need to refill my coffee here. Hope you guys brought yours. Have you been around the Orchard Ridge campus at all lately? I got this mug. My wife got it for me after I started playing Pokemon Go a bit. We got a couple of the kids into it as well around the neighborhood. But I was wondering, the Orchard Ridge campus, if it has any gyms or Pokestops, any good places to do it. I know at U of M Dearborn, they had a lot of gyms, and we had actually like an active group that would play, which was a lot of fun to go and do raids and stuff, because I was never able to catch raids around here with just the neighborhood folks. So, hey, look at that. Someone jumped in the Discord. That's so cool. It works. Yeah, so what she got me, this Snorlax is my favorite Pokemon mug, which is awesome. I love this one. And it's like giant sized. Like this is a 12-ounce can, right? And it's the mug next to it there. I can't show you the diameter of it very well without tipping it, but like compare that. Can you see it, maybe? It's nice and big, so it holds a lot of coffee. That's the whole story. All right. Awesome. So let me save this one. Again, I'll be taking this through next week at 6 p.m. Thanks for your flexibility. Yes, exactly, Face. Coffee, coffee, coffee. Spam those emotes. Uh-oh. I missed a space. All right. Hey, another person jumping in the Discord. Awesome. Yeah, hang out, ask questions. You guys are welcome to work on the projects too if you're so curious. I won't hold you to it though. All right, so let's open up Visual Studio, and I want to show you. Oh, let me show you Azure DevOps. DevOps.azure.com. There we go. So I'll show you the unit tests I got working. I just had to change. I was setting the options in the options dropdown instead of the actual YAML file, which sure. I just apparently read it bad, or maybe I'll blame the directions for not being clear enough of where to set that. All right, let's get logged in here. So I'd love to have you guys do this at some point, but I'm not going to require it for this project. Maybe for the next one, or maybe for the final project, we'll have something like this required. It's really good practice, and you get free time on their servers too, just for play with stuff like this. Let's see. Yeah, sign in. Isn't that what I did? I wanted to sign in. Did it not sign in? Maybe. There we go. That looks better. So, and I badly named it too. Like, I called this project Chapter 7, but it's hooked to my entire repository. A better habit might have been to make one repository per project. I mean, yeah, that's the right thing to do in the real world example, but it just is more awkward and more time consuming for us to do in the school example. So I just yeah, it's just one repo, because then that way you don't have to look different places. So I finally got the pipeline going. So here we go. Let's take a look at this. And here is the update I had to do. Come on, where's the... Oh, it's just not showing me. That's all right, I'll show you in a second in the GitHub history. But you can go to tests now, and you can see, hey, there were 5 total tests that passed. And all of them passed. By default, it doesn't show you the past tests, which is a little weird. So you have to like change your filter. What do I have to do? Yeah, this one here. I want even past tests. And then you can see the tests that passed. And you can click into the tests, and you can see, where is it here? Did I get a trace? I thought I had, no, okay, I thought it would show you the results on it, but not seeing it there. That's okay. Yeah, oh, I think if it fails, you'll see where it failed. All right, so we were testing our different areas and functions here of our circle and our car, adding some unit tests. This is the Visual Studio test framework because it's built into Visual Studio and was easy. There are better test frameworks, yes. I just unfortunately don't have the time to get into them. Gtest would be nice because we could actually use that then over in Macland or Linux if anyone's not using Windows. So, hey, thanks, Uncle Bill. That's pretty cool. Appreciate it. Yeah, shout out there for the Knowledge Fellowship, which kind of inspired me to stream my classes here on Twitch. If you do !TKF, you can get more information about other people who are just passionate about sharing knowledge, which is fantastic. So shout out for them. All right, so this is our main here, and we did these different things, and we did this terrible assert. Here, this is the poor man's cert, poor man's testing, right? We would say this AAA format. I'm going to arrange all of the things that I need to start. Then I'm going to act. Acting is where I'm actually calling my code to make it do the things I'm testing. And then I'm going to assert that I get the expected results. So we say, okay, I need a circle. Here's its radius. My expected diameter should be radius times 2. Right? The expected circumference, pi r squared. Again, we're approximating pi. There's better ways to do it, but this is close enough for now. And the expected area. I'm sorry, yeah, circumference, pi d, and then pi r squared for area. I know math occasionally. And then we'll get the actuals, right? Hey, here's what the actual is, here's what the actual is, here's what the actual is, by calling those functions of the class. So the class can tell you get diameter, get circumference, get area. All off of just setting the radius, which is cool. So and then we're going to go check. Hey, if they don't match, see out an error, see out an error, see out an error. So if you don't have Visual Studio, I'll take this for your testing. Okay, that's fine. We're making sure it works. Again, the whole idea about this is the computer is so much better at doing this than a human is. Especially as we're writing and running and writing and running and writing and running and tweaking and changing code. It gets really easy, just like if you write an English paper, or any sort of paper, I guess, to know what you meant it to say, and to, like, as you're reading it, you are just assuming that it is the right thing. The computer doesn't get bored and space out like that. The computer will say, yes, if it does not equal, we're going to get this big fat error. And in this poor man's testing, sure, it's a C out. We just have to look at our output, and that's all fine, well and good. That's okay. So I'll take this here. So this, your testing is separate from the simulator, right? You can't run all of the tests, and then I guess you can run all the tests and then run the simulator, because the tests shouldn't output anything, and that'll probably be fine for your poor man's testing. Now, the better way of doing testing, so let me start up a brand new project. We'll start from scratch here, because this is cool. It's definitely worth practicing. So let's do an empty C++ project. I've got it in my GitHub repository. We'll call this Chapter 7 Classes Part 2. Okay. Put that in the GitHub directory. Come on, Visual Studio, wake up. All right, here we go. So we are empty and blank, right? We'll add our source file. Right, source CPP, perfectly fine. Not too particular here. Oh boy, and include IOStream and int main, return a 0, and probably using that namespace, space standard, right? All well and good. We've got a source file here. Now again, this is, and the book actually has some good details about it, using just a header file versus using a header plus implementation file. There's some drawbacks and some positives. I like just putting it all in the stupid header file, and it makes my unit testing so much easier. There's ways to unit test without doing that, but it's a big pain. I mean, anything that's more steps is a pain to me, so maybe that's a bad assumption here, but we're just going to keep life easy and add it to a header file. Okay, so we'll have a header file. Technically, you can make them HPP files for header++, like CPP is a C++ file. As far as I can tell, no one cares. So, and the default in Visual Studio is .h, so I'm good with it. Don't forget, if you're not using Visual Studio, you can't do this pragma once. You have to do that if ndef junk. It's in the book. If you have trouble with it, let me know. But it's making sure we don't define it more than once. When we go include this file somewhere, it's actually going to load it. Essentially, when we include an H file, it's almost copy-pasting it into the other file, into source CV when we call include. If you are doing that more than one time, it's really easy for it to get confused because it says, oh, I see you've had the same method or the same class in here twice. Sure. Okay, so we're going to go and make a class here then. So let's make this a class for, what have we done before? We did circles, we did cars. How about we do, what's another fun one? Thinking here. Let's do a bottle. Do a class for bottle. Right, and it gets a set of curly braces, ending with a semicolon. Oh, people? Yeah, we could do people. The testing the verb might be a little trickier, though. I worry about like testing methods on bottle. So we'll just go with bottle if that's okay, Face. If you really want, we can try people, but maybe we'll do that one next. All right, so I've got a class for bottle. Right now it doesn't do anything, right? We're gonna have two sections. We have a public section and we have a private section. And now by default, if it's not labeled, it's going to be private. So some people say you don't need to use the privates because you just put them first, but I'm a big fan of having all the public stuff on top. So then once we have a public section, we need to then say, oh, now this becomes the private section. So I prefer this method here. And the other way is not wrong, it's just a preference, right? And so what bottle should do? So bottle should have a void method for set capacity. And we probably need to give it an int, I don't know, capacity in milliliters. Oh, I'm so bad at that. I'm just going to put ml, and I'm going to feel bad about it. All right, I'm feeling too bad now. Milliliters. Yes, got it. And we're going to do an inline definition. Again, you don't have to do this inline definition. You can do the method prototype and then later go define it in like a CPP file or even in the H file elsewhere. I just prefer these inline definitions. That's just me, right? If you go get a job somewhere and the people that you're writing C++ code for tell you to do it a different way, don't tell them, oh, Professor Charneski said to do it this way. Just don't. They're going to get pissed off at me, right? I'm just showing you this is one way to do it. If they say this is how we do it at this workplace, great, right? It's not going to make a big difference one way or the other, right? If you have super strong feelings about those performance gains or trade-offs, then sure, you can have that sort of discussion. But don't tell them it's because Professor Charneski told me to do it this way, right? Just don't bother. All right, so we got set capacity. We're going to need to set our capacity, but we need a place to set it. So we need a private variable, or we'll probably need an int capacity. Capacity in milliliters. Right, so we're going to set capacity in milliliters equal to capacity in milliliters. Now the problem here, you'll notice right away, is that what syntax would you use to access a public variable defined in a class from a main function? So it'd be, you need to make an instance of it first, and then it'd be the instance name dot variable. Control plus, if they bother. Control plus? Control, I don't know what control plus is doing for me, Blowfish. I'm sure it's some kind of magic. Visual Studio has so much magic, which is awesome. So right now it's telling me that I'm going to set the local variable capacity in milliliters to the local variable capacity in milliliters, not the bottle instance variable capacity in milliliters, this field here. So what I need to do is I need to use this special thing. This special thing. It's called this. So we say this arrow, which is dash greater than, I think. And it says this instance is capacity in milliliters. This will make a little bit more sense. Ah, the refactoring. Yes, yes, yes. Thank you. Awesome. Is refactoring here? Can I just have it create some sets for me? So we'll have a capacity, and then we'll have a current, I don't know what volume, I don't know, current something, current liquid, I don't know. I'm going to say current volume. That's probably the wrong term here, but that's okay. Current volume in milliliters. Can I refactor from here? Create declaration definition, change signature, move. No, I was hoping it would like do the method for me. Control dot. No, okay, that's all right. Some tools will let it make it for you. Maybe there's a way that Blowfish will tell me, or we can do some Googling. So we've got the capacity, and then we have the current. And we probably also need a get. So I'm going to have an int method for get capacity. And we probably want to leave this in milliliters, right? We'll be nice and specific here every single time. We return capacity in milliliters. So we're going to set and we're going to get. The other good things you get to do with set methods, right, is have some sort of integrity to your class. Oh, yeah. If you just implement it as a prototype, it'll do that for sure. Yep, into a CPP. Yep. Yeah, we did that last week, I think. We just did them in the same file, which at that point seemed silly to not just inline them, but maybe that's just me. So we set and the get, and our set here should probably do a quick little sanity check. We're going to check if my capacity in milliliters that you gave me is less than 0. We're going to set this capacity in milliliters, to 0. Right? If you try and give me something negative, I'm just going to set it to 0. Otherwise, I'll take it. That make sense? So the other value we get out of having these public methods, these mutator methods or set methods, is that I can control possible values. I can also sanity check and say, hey, it's not more than 1,000,000 milliliters or something. Like, I don't know, maybe we have some containers that can hold that many liters, but I mean, I don't think most households would have anything that'll hold, what would that be? So 1,000,000 milliliters divided by 1,000. Is that 100,000, 10,000? Is that 1,000 liters? 1,000 liters is still a lot of gallons. And I don't actually think in liters, so let's look that up. So what is 1,000 liters to gallons? Yeah, you probably don't have a 264-gallon container anywhere. Like even big coolers and stuff, I don't think fit that. Even refrigerators aren't even that large, are they? I don't know. All these kind of questions that pop into my head as I'm doing stuff like this. So it's all fun. All right, so we've got capacity in milliliters, getting and setting. And then we'll have our current volume in milliliters with gets and sets. So we'll have a void set current volume in milliliters. Or again, this might be like an add. So maybe not a set is appropriate. Maybe we have an add, I don't know, something, add milliliters. Milliliters of something to bottle. You got a game? Which one do you need? Looks like the kids are going to try out Color Brain tonight.
Did they see that?
Yeah, that's on my web. It's slow. There's like a little delay.
Oh, there you are. That's weird.
Yeah, just a small delay, thanks to the magic of the internet. All right, so I don't know, add milliliters of something to bottle. Sure, and we'll tell it the int milliliters to add. Milliliters to add. And now we probably also need some sort of sanity checking too, because if our current volume is at capacity, we're not going to add additional. Right, but we can try it. So we'll take our current volume, we'll plus equals the milliliters to add, and then we can sanity check. If the current volume is greater than the capacity, then let's set the current volume to capacity. Right? Everything else just got spilled out. Some sort of error should probably happen here, but we haven't learned how to do that yet. And outing messages from inside a class is a giant pet peeve of mine, and we're just not going to do it. Right? Because the idea that our class here is it's self-contained and you can interact with it and do things in any sort of setting. I could use this class because my bottle class is so amazing and reusable that I might use it in a web application or a mobile application, or I might use it in some sort of graphical user interface program, or I don't know where, right? Put it in some embedded system, in a vending machine, right? I don't know. But not all of those systems will be where someone is going to be looking at cout, right? Our standard output. So outputting errors inside a class is a big no-no. Right? Well, so maybe we'll add a note here. This is bad, but we don't use cout to tell people. There's better ways to do things. I probably shouldn't shout at you. Cout. To tell people, right? We'll get to that once we get to exceptions. And when do we get to that? I should look that up, shouldn't I? When do we talk about exceptions? Come on, desire to learn. Let's load. Come on. Oh my goodness. I don't know why it's so slow. Come on. I got to page 12 of 8 somehow. That's what happens if you click too fast. How about page 8? There we go. Yeah, we don't get to exceptions until December. So, sure. It's a little unfortunate, but that's how the book's laid out. So we'll go with it. Yeah. All right, so we can add milliliters of something to the bottle, which is just a void. Oh, here's what we could do. Maybe this will be a bool type variable here. And if we overfill, we'll return false, like something bad happened. Else we return true. Return true. There we go. Okay, so if we return a false, I mean something bad happened. Otherwise we return true, it added perfectly fine. Okay, how's that sound? I like that. I like that a lot better. And we'll have a similar for pouring something out or removing from the bottle, right? I don't know. So make that a Boolean function. Pour or remove milliliters of something from bottle. You know, this to bottle is actually kind of redundant because it's happening on the bottle class. So I'm going to remove that. There we go. I like that. And we need to tell it the milliliters to remove. Okay. And we'll do the same sort of thing here. Okay, so now I can probably get rid of that comment now, which is nice. So we'll take our milliliters to remove and we'll subtract it. And now if we're less than 0, we just set ourselves to 0, return a false, otherwise we return a true. Right? The operation worked. Yeah, avoid any false inputs until exceptions, or avoid them until the end of your lifetime. If only it was that easy in the real world, Blowfish. I would love to teach more defensive programming, but we just don't have exceptions yet, unfortunately. We'll get there. We will get to exceptions, I promise, and then I will not feel so terrible about myself for telling you to just forget it. Because it is a pet peeve of mine. I don't know. Do things annoy you? Does anything annoy you more than during your day when one of your programs crashes, or like an app on your phone crashes? Like, as a developer, it frustrates me because that sort of thing shouldn't happen. And I know it's like almost impossible to have not happen ever, and sometimes it's just like Android's fault or iOS's fault that it crashes, but I don't know. Like, it just ruins your day real fast when when your program crashes for some reason. Then you go through your meditation and your deep breathing exercises, and you breathe in and you breathe out, and you just repeat that mantra to yourself. Like, it's okay, just an app. It's just an app, right? Like, I don't know. Before we had everything on computers and our phones, like, it wasn't a problem that would frustrate us so much. So anyway, so we got our bottle, right? We can do that sort of thing. And I don't know, should we have anything else? Or is that enough for now? I think that's enough for now. Let's try some unit tests. So 2 steps for unit tests. 2. Where's the webcam? 2 steps. Right click on your solution, and we want to add new project. Again, this is the not poor man's way. We want a native unit test project, or if you just search for test, you'll probably find it here. Just make sure you're looking for your C++ stuff. It's got a package for Google Test already. Again, I just haven't fiddled with it at all yet, so I'm just lazy and use the native unit tests. I like calling it unit test 1. I don't really care. Not too particular here. Yes, users are very creative, Blowfish. Have you seen the funny QA shirt? That one's worth looking at. Quality assurance is amazing, by the way. And people who are good at that sort of thing, like picking programs apart, are hilarious. Oh, here's the shirt. There's the shirt. Oh, is it one of these? Which one's going to load first? Come on, my internet. Yeah, this one. Come on. So a QA engineer walks into a bar. So quality assurance. Their job is to make sure that code is of high quality and doesn't crash. They order a beer. They order null beers. They order 1.33 beers. They order a lizard. They order -1 beers. They order emoji beers. It's just that sort of thing. Like the kinds of things your users will throw at you never cease to amaze me. And I always like to joke that QA engineers, their whole goal in life is to put us developers out of a job by showing everyone at the company that we're terrible developers and we have so many bugs. And our job as developers is to put QA engineers out of a job because they should never find stuff. No, but it's definitely a very collaborative process there, and it's good QA engineers are totally worth every penny. They provide so much value to make sure you have a solid product. I get upset by a lot of things, I guess, but one thing in particular that upsets me is when companies ship software and expect end users to be their quality assurance testers and have all the end users be like, oh, I found this bug, I found this bug, I found this bug, I found this bug. And even if they can turn around and fix it relatively quick, like it's just sloppy. And it just makes us look bad as professionals. So it just upsets me. Yeah, Cat walking over the keyboard, pulling out the internet connection. We actually had something happen one time. We have alerts for our software that would tell us if someone was looking at like breaking into our application, like by trying to log in over and over and over. Typically that's an indication of someone trying to hack your site and just do some sort of like rainbow attack where they're just trying all these different passwords. And this poor guy, we got an alert that he tried to log in. His account tried to log in like 1,000 times in a matter of a minute or something like that. So we reported it, and his IT folks there who supported him couldn't figure out what was going on with his computer, so they actually reloaded his whole computer. The poor guy got his entire computer reloaded, probably spent a whole bunch of time having to reinstall all of his software. I mean, they're getting better at it now, but it still takes time to do that. And what turns out is he set something down on his desk on the enter key. And our app was not smart enough to say, hey, if you're hitting enter on the login page and you don't have a password entered, because it saves the username, right? Like, hey, save your username here and then type in your password, that we weren't blocking that from getting submitted with no password. So we did find that out after it happened again, after it got reimaged. So that was fun. Anyway, funny story. Where did that even come from? Our unit tests. Our unit tests. That's right. So we added a unit test project here. That's step 1. Okay. Now step 2 is we come to references in the unit project test. Unit test project. We add a reference. We say, hey, I want this project to reference this project. Ooh, home office and runnable on Citrix. Yeah, Citrix is a fun animal for sure. So you right-click your references in the unit test project and you say, I want to reference this other project. Then we come to include, and now we don't use the greater than less than signs. We need to give it a relative path to the H file. So it's actually up a directory, because if you look at your solution, right-click at solution and say, open folder in File Explorer, we're going to see the solution directory. and inside of that we'll have a directory for each project. That's my default. Some people now put projects inside the same directory. Sure, doesn't actually matter much at all. And maybe that makes things easier for doing this sort of stuff. But for me, unit test is here inside of this folder, and chapter 7 classes part 2 is inside of this folder. So to reference that H file, I need to go up a directory. That's / chapter 7 header. Oh, I should have renamed that one. Shoot. Let me rename header.h, because this was bottle, right? Rename all that bottle. And I'll rename this one here to bottle. Okay, we're including bottle. Did it work? Good. All right, now what we're going to do in here, we're going to do this AAA method. We're going to arrange, we're going to act, and we're going to assert. I think it works with either. Technically, they're backslashes in Windows, but I think Visual Studio is smart enough to figure it out one way or the other. That's always been a point of contention between Unix and Windows, is // and backslashes. And I think Windows has just gone on long enough that they're not going to change, even though we all wish they would. But that's okay. Yeah, both should work. Man, I get such a dry mouth sitting here talking for hours and hours and hours. It's also really boring, so I love that you guys are chatting at me. It makes this so much more fun. I really do miss being face-to-face in the classroom, where like we can actually talk back and forth. And if you want, I can hop on the lecture voice chat channel in my Discord server, and you can talk to me instead of chat to me. And I think I set it up right in OBS, so no one will hear your voice. Although it might come up on my mic. I might have to try it. Maybe I'd have to use a headset or something. But yeah, the backslash is the problem. So pathing is really annoying. Anyway, so we're going to arrange, we're going to act, we're going to assert. So we're going to create a bottle. So the first thing we're going to do is say, these are the things I expect. Right, so we're going to have a bottle. We'll just call bottle. I'm going to use this bottle class. Right, it turns this nice little light blue color here. Right, we're going to have it. We're going to have an int for expected capacity. And if you want to put in milliliters, fine. I don't care at this point. It's not too big of a deal. Let's do, how many milliliters are in 12 ounces? We should figure that out, right? 355 milliliters. We'll have a 12 ounce can. We'll have an int for expected volume of liquid. I don't know, sure. Of something. Well, we'll say we expect that to be, well, we're going to fill it to 355, and then maybe we'll take some out, and maybe we'll say we have 300 left. Okay, let's try that. So we've arranged some code, and then we're going to act. Right, this is the act portion. This was arrange, and then we're going to act. So we're going to call bottle.set capacity milliliters to 355. Okay, and then we'll have an int for actual capacity in milliliters, actual capacity, fine. Is the bottle.get actual capacity, get capacity in milliliters, great. And then we can assert. So it's assert : this is the assert namespace. R equal is what we're going to use most of the time. Again, not always, and you give it the expected, and then you give it the actual. So we expect the expected number, expected capacity, and it's actually the actual capacity, right? Well, we actually got back from calling our code. Oh, I forgot to do the whole test-driven development thing for you. That's what we were going to do last time, where we turned all of our red X's into green check marks. You got to remind me. That is actually lots of fun, and I seriously mean fun, because I'm weird, but it's entertaining to do that sort of thing. Okay, so we've got that, and then let's, you don't always. You kind of want to test things one at a time, so I'm going to take that one out. Let's leave this here. This is testing capacity. Okay, so we test capacity, sets and gets, because we're setting and then we're getting, right, to see if it works. Now we're going to test volume here. So we've got an expected capacity. Oh, yeah, that's silly. I should use my variable here when I actually set, not the 355 hard-coded. We got an expected capacity, and then we have an int expected volume, was we said 300 or so. So to do that, right, we don't need that actual capacity anymore. We need to call bottle dot add milliliters of something, and let's just add our expected volume. Oops, expected volume. And then we'll get the actual volume. So now we have an int for actual volume is my bottle dot oh, we never added the get for it. Oops. Yeah, most testing frameworks are really similar. We need a get method for get volume, right? Get current volume. Get current volume of something in milliliters. Milliliters. Return our current volume. There we go. And we got a method to test. So bottle.get current volume of something in milliliters. It's a terrible variable name. I'm feeling a little bit bad about myself, but that's okay. So we have an actual volume and we have an expected volume. Oops. That one. Right, and then we can run some tests. Oop, equals 300. Oh, geez. Come on. So you can get to that with the test menu here, and you can say Test Explorer. And hopefully it's over here on your left is where it usually is. And you can pin it or not, depending on if you want to. And you should be able to say run. Here we go. Oh, you got to build all or run to find all of our tests. So let's give it a shot. Let's see if it finds our tests. So this is the kind of thing we're going to do for that project too. We're going to write our classes. And again, I prefer one class per file. I don't care which way you do it, one way or the other. If you want to put them all in one H file, that's fine. The reason I like one per file is that it keeps my GitHub history or my Git history cleaner. So I can look to see the last time that individual file was modified. Will tell me the last time that class was modified. It's thinking. It's not the fastest thing in the world, I apologize. And that is another benefit of hooking this up to that continuous integration, is that I don't need to actually go do this. I can commit my code and then keep on working on something, and then 30 seconds, a minute later, go see what the continuous integration engine says. All right, I didn't find any, so I need to build my solution. Okay, let's try that. Let's build solution. See if we get any errors. It built, so let's try and run again. Oh, come on. Did it not do it? All right, I'm going to try rebuild. Sometimes we need to rebuild. Come on, let's work. This part worked great the other week, right? It was the continuous integration testing I had problems with. Yep, found some tests. Come on, found some tests. There we go. There we go. We found some. Can we run them now? Run. I don't know why my run all button didn't work. That is weird. Yay, green check. Green check. We love green checks. Let me try run all again. Run all tests. Maybe I'm just not patient enough. That is quite possible. Uh-oh. Test volume. Expected 300. Actual negative. Ooh, that looks like a garbage value. Like we never set that value. So we called set capacity. I'm sorry, we called set capacity and add milliliters of something. So we added milliliters. So what we can do is we can put a breakpoint in, and this is fantastic. Come to the gray space here, add a breakpoint, and we're going to debug this test. This is why it's fantastic. We're going to run debug, and we're going to see what happens inside of the code as it's running, because we love the debugger. My favorite feature in Visual Studio. Again, it's not the fastest thing in the world, but that's okay. We'll get there. Oh, and let me commit it here too while I'm at it. So we open up my GitHub client. I'm asking my computer to do too many things. I swear it's a decent computer. I think it's OBS that slows everything down, because it's sitting here eating 13% of my CPU constantly, just sending the stream out. So I will blame OBS, and I will not apologize. Come on. $2252. All right, so let's go add all of these files here. So this is classes part 2, getting started. Commit, and then once I push our continuous integration testing, our pipeline there in Azure DevOps should pick this up, which is really cool. And it'll run the tests for me while we figure out what went wrong. So I'm here, so I want to step into my code. And it's going to jump me into the bottle class here for get capacity in milliliters. And we can step. Oh, add milliliters. That's where we are. So my current volume in milliliters is a garbage value. Oh, crap. We never set it to 0. That is unfortunate, isn't it? Sorry, my phone should be on silent here. Aha, this is actually a perfect segue into something we're missing. We are missing a class constructor. Class constructor. So a class constructor's job is to set default values. So I'm going to write another method here in public. It's going to be called bottle. So the constructor is the name of the class. And you can accept arguments if you want. We can look at parameterized constructors in a little bit. But by default, this is my default constructor if it takes no arguments. Now, C++ will give me a default constructor, but it gives me garbage, which is really frustrating. So I am a fan of always writing your own constructor. The constructor's job, right? We can highlight this here. Constructor, and you know it's a constructor because there's no return type, and the name matches the class name. Constructor job is to set default values. Okay. Aha, look at that. It's even telling me, hey, capacity in milliliters is uninitialized. Always initialize a member variable. Current volume in milliliters is uninitialized. Always initialize. Hey, will it do it for me? Can I get a quick action? Refactor? Oh, nope, that's okay. So what we need to do is we say capacity in milliliters is 0. And then we say current volume in milliliters is 0. Right? We're going to set some defaults. And now it should stop yelling at me. Perfect. Okay, so now when bottle is created, this default constructor is called. So if we put a breakpoint here, we're going to take a look, and it should actually trigger right here at bottle. Let's put a breakpoint there. Okay, we'll debug this test again. We're going to debug test. We're going to watch it. And while that's happening, right, while it spins up, let's see if we can take a look at our pipelines and see if we get a failure here as well. Look at that! We got a failure! I don't know why I'd be so excited. Yeah, the initializers we're going to look at in a little bit. That's a little farther on in the chapter. Look, it says, oh, it failed. Might be a failed test. Oof, those are some ugly errors. Yeah, just VS test failed. So what happened here? Right here, it says, oh, it just failed. There are not better. Come on, that's a terrible looking log. Oh yeah, so it didn't even show us. That's unfortunate that our test failed. Huh. Okay. It was not the prettiest failure there, so that's okay. We'll go fix that. So here's our debugging, our unit test. If we step into, we're going to see calling bottle here, making a new bottle, calls the bottle constructor. And now we don't get garbage values. We get zeros instead of the garbage values, and life is good. So we can continue. We'll step over here, and now we see our current milliliters goes to 300. Okay, so life should be good. We'll continue on, and our test should pass. Does that make sense what we found? Now let's check out Test Explorer, and now it passes. So let's go commit that fix. So we're going to say we added constructor here, commit and push, and hopefully that fixes our problem out in the automated unit testing. So we'll take a look here in a minute, and it should trigger another pipeline run here. Come on, it's pushing. It's pushing. Maybe. All right, while we wait for that, it is 7:04, so we've been going for a good hour strong. Again, we try and take a break every hour or so, so why don't we take 10? We'll pick it back up at 7:15. Let me find some more music here. Spotify. And we'll be back. Oh, did I have that on when I started? I'm so dumb. Okay. Lecture resumes at 7:15. 15-ish. Okay. Let's see if I can get some music going.
Don't know what we're doing. Things are about to change, it's evolution. Wait to shake the ground, you feel it moving with the revolution. with you, boy. Real, wasn't real with you, boy. You won't give me too much chances. I don't care if I am fencing brighter. Yeah, yeah, oh boy, I'm telling you goodbye, I'm telling you goodbye. Yeah, oh boy, I'm telling you goodbye, I'm telling you goodbye. I'm not the girl that I used to be. Sometimes I'm more than words. I'm beyond what I once was. I don't believe in love. Hey, hey. If I want something, I got it. Hey, hey. Oh, baby, I need love me. Hey, hey. Cause I love, I cannot buy it. Wasn't real with you, boy. Real, wasn't real with you, boy. You won't give me too much chances. I don't care if I am fencing brighter. Yeah, yeah, oh boy, I'm telling you goodbye, I'm telling you goodbye. Yeah, oh boy, I'm telling you goodbye, I'm telling you goodbye.
Alrighty, folks. Hope you had a good break. We are back. Maybe if I hit the right button, we'll be back. There, now we're back, right? That is the correct button. No apologies at all, Blowfish. I appreciate it. It's all good stuff. Alright, so we passed our tests. We committed. Hopefully we had a new pipeline build here. Let's see. Refresh. There it is, and it's green. Look at that. We should be able to see our tests. They're passing. Life is good. Again, the next really cool thing that happens with this sort of pipeline is you can go from continuous integration testing to continuous deployment. So you might hear CI/CD, continuous integration to continuous deployment. Again, our silly little application here is not something we deploy right away, but once we have continuous integration done, we should have a pretty good feeling that if our tests pass, our code should be ready to deploy to production somewhere, or even maybe just a test environment somewhere. And that's all sorts of other software engineering stuff you can get into later. But without this pipeline, you've got almost nothing. No chance of that. So I'm definitely a fan of that. Yeah. So this sort of thing is what we're going to be doing for our testing here. And now let's take a look at how we can do some random messiness here, because that does get difficult. So say we had here in our bottle class, we had remove milliliters of something. Let's just have a void function for remove random amount. And that's not going to take any arguments. And all we want to do is subtract some random number of milliliters. Right? Why not? We could try it. So we need to be using random, and we probably want to seed our random here. So a couple things. If we want to keep random around and not have to make a new random number generator every single time, we might make it a class level variable and say, hey, I've got a private variable for random that we can create in the bottle constructor. So I kind of like that idea. So we're going to include, ctime, and we're going to include cStandardlib, I think it was. Does that sound right? And then we say random, right? Oh my goodness. Okay, I just got to go look it up because I'm not remembering off the top of my head. Let's go check our GitHub. Right, we got that. 2252. Because we did this once already. Let's search for random. I know we did this. Oh, just srand. We didn't even have to add any usings? Really? No, we did. Okay, we did. I'm not going crazy here. But where did we get random? Oh, we just seeded random. There we go. So we're going to seed random in our constructor. Right, so that seeds it with the time at which this instance of bottle was created, down to the millisecond. Then we need random. Rand, there we go. And remember, random gives us a really big thing, so we're going to modulus it by some number here. So when we pour out some random number, say I want between 0 and 100, rand mod 100 will get me between 0 and 99. I can't get this number, because if I evenly divide out by 100, the remainder is 0. So if you want 0 to 100, you need to go from 0 to mod 101. We'll get you 0 to 100, but we actually want like 1 to 100. So we're going to take that and we're going to add 1 to it. So this is our int mLs, milliliters to remove is random mod 100 plus 1. So we're going to get between 1 and 100. Between 1 and 100, right? That sound okay? And then what we're going to do is we're going to try and remove. Then we're just going to call ourselves. We're just going to call remove milliliters to remove. Because I don't want to have to repeat any of that arithmetic, right? I already know how to do it. I'm just going to generate a random number and then remove it. And we'll see what happens. That make sense so far? No questions? All right. So this is going to be really hard to test though, right? Because we're seeding random. Right? You're shaking your heads. Yeah, that's going to be hard to test. So we've got two options. Right? One option is we cheat. And we actually take out... Yeah, it has to be less. We could check that it's less. But we want to make sure that it's... You know, we have some control over it. We could check for less, and maybe that would work. The other option is we pass it a seed value. So maybe we tell it, hey, I want to seed a certain value. Right, that's one option. That one's not the greatest, but it could work. it could work. So basically what happens here is we're saying my class is dependent on this random function. And if I don't have control over this dependent function, I can't really test this as a unit. Right? So we need to sort of invert, we need to change what's happening. So we need to say, I'm no longer dependent on this, but maybe I give it something that can generate a random number. Or we can just give it the seed value. So until we do a little bit more with inheritance, and we get to that, when do we get to that? That is a little later on. Yeah, polymorphism, virtual functions. I think we get to that in this More About Classes, chapter 11. And this, yeah, so we don't really have the right tools to do proper dependency inversion, where I would hand model a random method that I can use. You know, this will get the job done for now. So what we can do is we can pass it a seed value instead of using time here. Okay, or we can have a second constructor, and this leads in pretty well for this. So we can have a second constructor here that will now take a, what is this one here? That's a time t. I don't know, some kind of big number here. srand wants an unsigned int. Well, we'll just say an int. Fine. That should be fine. For a seed. So we can have two different methods with the exact same name. And it's not just for constructors, it can be for other things. Did we get to that? I don't think we got to that one yet. As long as their parameter lists are different, we can have these overloaded constructors. Which is kind of cool. So what that's going to do now is we're going to srand using seed if you give it a seed value. If you don't call that one, we're just going to use the random one here. And it says we should initialize. Yeah. Okay, let's I think we can get away with this. Let's try it. I don't know if it'll like that or not. No. Oh, okay, it does. It does. Cool. So we get this cool syntax. If you want to save some time, we can say, hey, this constructor, if you call it, will call this constructor, and here's the argument it's going to give it. So this is calling, so this is the default constructor with no arguments, constructor, no arguments. It calls the parameterized constructor given this argument. So if you don't tell me what seed to use, I'm going to use time of 0. If you do tell me the seed, I'll use the seed. So both are available for when we test, which is cool. So right now we don't need any of them. It'll use the random one, which is fine. Or we can test the, now we can test the random. Test random removal. And I don't have an expected volume, right? Because I don't know what it's going to be yet. We'll get there. But let's set the add to the capacity. And then let's remove random amount. Oops, I'm sorry. That one's not an int here. That's right. Shoot. Get current volume, and so bottle dot remove random amount. Oops, nope. Remove dot remove random amount. So we're going to set the capacity. We're going to add it to the max, and then we're going to remove some random amount here, and we'll check what it actually is. So I don't know what it's going to be right now. But what I'm going to do in bottle is I'm going to give it a seed value. It doesn't really matter what this number is here. I'm just going to pick a number. And I'm going to run my test, and it's going to fail because I don't have... I'm going to bet it's not 55 milliliters that our random number was. Let's take a look. Oh, one failed. All right, come on, Test Explorer. There it is. Test Explorer. So we had actually 279, expected 300. So let's have an expected volume. Let's try it again. Let's see if we pass. Because every time we run it, if we use the same seed value, oh, not the start button, not the start button, oh, the run test button. Every time we run it, we should get that same value. Come on, run test. Let's take a look at Test Explorer. Just thinking about it. There we go. Awesome. So it matched that time. So if we give it a seed value, right, we're actually controlling that dependency because we know what it's going to be. Now this is not ideal all the time because maybe you don't want to give people access to that. And I get it, and that's okay. So maybe Blowfish's suggestion was just as good. So let's try test random removal is less. So I'm not going to even have an expected volume anywhere. I'm going to set it, add something, remove something, and then I'm not going to even use r equal here. I'm going to use assert is true that the actual volume is less than the expected capacity. Right? So if I fill it with this capacity and I take some random amount out, it should be less than. And that's a fine test here, right? We can give that a try. So maybe we don't know the specific amount. We'll get rid of that bottle constructor call there. We'll just take the default, which is the time. Oops. Why is it saving? Save, run test. Run test. Oh my goodness. Run test. Come on. Run. Did it already run? What's it doing here? Alright, so we've got two options then for our testing. Either one you want to use is fine. So this has overloaded constructor, constructor to control random. Commit and push. So for your project, right, if you want to be able to say that the market money that will change between 4% starting and then go up or down 6, we don't actually know if that's going to be greater than or less than our original value. We just know it might change. It could even be 0, right? There could be no change at all to it. So that one is difficult to test unless you're doing this fixing the random seed here. So that might be an option for you, is have it take a random seed so you can control that randomness, what's happening there. Okay? So I think this might be the approach you want to use for testing out that market money account in project 2. That make sense? But if you can give it a seed value, then you'll know what the change was, and we can test that, hey, every time it does the right thing, because we know what the seed is. Right, with our constructor, we can set the seed here. That makes sense for now? Maybe? Let me pause here for a minute, see if there's any questions. Just going over, making sure we're not missing anything out of the chapter here. Yeah, I think this will be the easiest way for you to test. I mean, most of the time it should change. You know, depending on how you're calculating that difference between +6 and -6, whatever your options are there. Again, it's just some arithmetic with your, you know, use a modulus and add, subtract something or other. Right? I think you'll get the right number there to get a +6 or a -6 from 4. But testing that it changed, it might not work every single time, and typically it's frowned upon if your test occasionally doesn't work. I can't say that it doesn't happen, but ideally we want to test that it's working as expected. So maybe you set it up to take a seed value, and that's one way around it for sure for now. Once we get into a little bit more advanced stuff, I can show you a better way to go about that. But that's what we got for now. bean juice. All right, so we got constructors, overloaded constructors, default constructors. Let's see. Invoking constructors. Yep. Aha, okay, so a member initializer here. You can, if you like shortcuts. So this one here is saying the default constructor is bottle with no arguments. What this is doing is saying, hey, I want to call the overloaded constructor, call a different constructor here. And it's going to call the constructor that takes one argument, and that argument is going to be the time. So we're calling a different constructor from that constructor. So that's constructor delegation is the technical term for it there in your book. Constructor delegation. So say you call this one, actually run this one here. Okay. The other cool thing we can do is this member initialization. So instead of doing this, people said, hey, wouldn't it be faster if we could say current milliliters is 0 and current volume is 0. I don't like this. I'm not a fan of this syntax at all. So I will probably never ever use it. But you can. That's the member initialization. And actually the other reason I prefer not to use that is this is even kind of a little bit naughty in that I should probably be using my set method here to 0 just to make sure that the code that I wrote inside of set runs. Because maybe I'm going to change this this sanity check later and say, hey, maybe 0 is not a valid value. And if I change it here, I'd have to remember to go change my hard-coded value. Yeah, I mean, people love the member initialization. I prefer calling my set methods. And I guess technically it's a little slower, but sure. I don't know. Not too concerned about it myself. I've got the luxury of not dealing with like a lot of embedded code or small microsystems and stuff where that sort of performance really matters. So maybe I'm spoiled. So we can mix and match. Why don't we do that? We'll say current volume is 0 here. And we'll comment this out because used the member initialization above. Okay, just an option for anybody who wants it. So that's just our list for initializing. We can set some values here, which is kind of cool. Yep. Good. There's another special method you can write. It's not actually going to do anything for us at the moment, but it's a destructor method. Once we talk about pointers, which is 2 more weeks, then we're going to have to start doing things with destructors. For now, we don't really need to worry about it. It's a special method. You just put a tilde character. That's the shift accent grav. I think it's an accent grav character, or backtick, other people like to call it, character. That's next to the 1 on your keyboard. You do that, and then give it the name of the class here. And no return types. And this tells you how to remove the class or delete the class, essentially, when it is being cleaned up in garbage collection. We don't have anything where that matters yet, and none of those terms make any sense, because we just aren't there yet. So I'm just going to skip it, because you get a default one anyway, which is nice. So yeah, that should be fine. No arguments, no return types. Can't overload it, you just get 1. Another fun thing you can do in this private section, you can add not only attributes of your class, you can add private functions. So if you want a function that's what we'll call like a helper function, you're going to use it because it's helpful, puts a nice name to what's going on here, and lets you avoid repeated code, but you don't want people to be able to call it publicly, you can make it a private function. That's perfectly acceptable. You can use it anywhere inside of your class, but it's not exposed in that public API. Remember, we have this idea of this abstraction. we want our classes to be interacted with abstractly. We don't need people to know the details of how we do our processes. All the people need to know is that we offer functionality and they can get at it through our public methods or our public functions. That's sort of the pie in the sky view. Everyone is going to love this bottle class and it's going to be so reusable. I can use it so many different places. Yes, I mean, there are definitely pieces of code where you reuse all over the place. And people write amazing libraries. There's some really smart people out in the world who've written some really amazing code that does get used everywhere, right? But, you know, for the things we're doing, I think that's a little bit more it'd be nice, but maybe we don't get there. All right. So for passing objects to functions, yes. Okay, so we can pass arguments, right? When our functions want arguments, we can pass by value or we can pass by reference. Does that ring any bells to when we were playing with our functions? Was that 3 weeks ago now? Let's take a look and see what we did with that one, because I want to pull it up. Let's see. That was chapter 6 was functions, right? What are we doing here? Enhance, 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 enhance. Aha, so we did a little bit of pass by reference, right? Does that ring any bells? This little ampersand or and character would say, hey, I want to pass this by reference, not by value. Because that way you can modify the value stored there because you have the reference to it, not a copy of it. Oh yeah, we did overloaded functions, right? Where as long as this argument list or the parameter list is different, that's the signature. Remember, it does not include the return type. Yes, no, maybe? Man, so running out of fluids. That's a bummer. I'll have to get more later. Maybe? Anybody still listening? You all just drinking your coffee? Multiple return values. I mean, like, we're returning a single value here. We could use pass by reference to essentially, quote, return another thing. People do it. Yeah, it's one way. You're not even in the class, Blowfish, are you? You're the only one talking? All right, Joseph, you're there drinking coffee. I like it. Thank you. So, when you pass something by value, you're passing a copy. All of our primitive types, right, do that. Passing by reference allows us to change it in place because we have a reference to that value. And now what happens is when we use classes, right, say I was going to write a function here. Let's actually go back to our main method here. Let's write a function for, I don't know, it'll be a void function for drink bottle. And you have to give it a bottle to drink from. Bottle. And maybe this function asks you how much do you want to drink. How much do you want to drink? And then we can see in, we probably need an int to see into that, right? Int. I don't know, drink in mLs, milliliters. Oh, it says it doesn't know what a bottle is. Okay, so we need to include bottle. It's fine, no problem. Include bottle.h. Okay, if I pass in a bottle here and I go drink from it, right? Let's get that, and I'll call bottle.remove milliliters of something, right? Given drink in milliliters. Nope, drink in milliliters. Come on, search suggest. Right, and then maybe we see out. Bottle now has bottle.get current volume of something in milliliters. And maybe we add in, you know, mLs. Milliliters. I'm feeling bad every time I don't type it out. I don't know why. I guess that's silly. All right, that's kind of long, but that's okay. You get the picture there, right? You can see it. So I can hand bottle to a function to drink from it, and I can drink over and over and over. Right, so maybe we'll do a loop here. Well, let's do a do while loop because I hate them and I should practice them more. While we'll have a char for again equals y. While again dot. Is it lower? Lower again is equal to a y. Is it 2 lower? 2 lower? Yeah, 2 lower. But whatever they entered, right, to lowercase again. We'll say we'll drink from bottle. We'll call drink bottle. Oh, so we need to make a bottle, right? So let's have a bottle, and let's take my bottle. Let's set capacity to, I don't know, let's make this a ½ liter. Why not? And then bottle. Let's add milliliters of something. Let's fill it up to the top, and let's keep on drinking. Right? So we're going to keep doing this. We will call my drink bottle function given the bottle. Okay? And then we'll ask if they want to do it again. So again equals or cout drink again, y/n. Right? You know, give them a little suggestion here of what they should type in. And we'll see in character. And this, because it's a do loop, needs a semicolon at the end of the while condition because it's stupid. I hate that syntax. I don't know why they make you do that, you know, but whatever. Maybe so you know it's not an actual while loop. I don't know. Whatever. Okay so far? So let's try it. Let's see if we can drink some beverage. Come on, did it run? Oh, no, not test, not test. No, I want to run this project. This is my startup project, isn't it? There we go. Did I hit the wrong run button? Maybe I did. How much do we want to drink? Let's drink 100. Now it has 400. Drink again, yes. Drink 100. Now it has 400. Drink again. Let's drink 500. Now it's empty. Drink again. Drink 100. It's down to 400. Something not right here, right? You get the feeling that something is a little bit off, right? How did I keep getting a full bottle every time? Well, what happens here, what we passed is not the reference to bottle. We passed it by value. We passed a copy of bottle to my function. Oof, ouch. So every time we were interacting with it, we were interacting with a new copy. And when I was done with my function, right, when I was done with this drink bottle call, we come back, my bottle has not been changed because it had a copy of it. So what we need to do, or usually what you want to do, right, I guess depending on your use case, is say, hey, I want a reference to bottle. Give me a bottle reference so I can keep drinking from the same stinking bottle every time. Let's try that. All right, how much should we drink? Let's drink 100 milliliters. It has 400. Drink again. Drink another 100. Now it has 300. Drink again. Drink another 100. 200. Drink again. Another 100. So now it stays modified because we gave it the reference here. It was able to, using this reference, interact with it using its public functions. How's that part feel? So that's passing an object by reference. Right? Maybe? You guys are not talking much. I'll give you a second to think about it. So if we're not passing by reference, we're getting a copy. We're getting a copy of bottle is being handed to drink bottle. So this bottle here in main is not affected. And every time we call drink bottle, we make a copy of this bottle, and it's a copy of bottle up here. It's a good question. Yep, yeah, we get a copy of it. And that can have its own sorts of trouble later on as well. We do need to be a little bit careful with dealing with copies. Again, it's not going to make a whole lot of sense until we get into pointers and other things like that, but copies can be dangerous too. Just in terms of memory leaks, and that's another reason C++ is super powerful and you can do some really cool stuff with it, but it's dangerous. So we'll pass by reference here. And the other thing, like, you don't actually know that you're passing by reference until, like, if you hover over and look at it, be like, oh, it takes a reference. So to the person calling the function, it looks identical, whether or not you're handing a reference or a copy. Looks the same to us. So it's defined in the function of what it's taking, which is a little bit weird. Okay. So using references is faster, right? Because we're not making copies. Copies are technically slow. What you can do, if you're not going to change a function, you can use that constant operator. Remember when we had like the constant for our version of pi or whatever it was? We said, hey, it's a constant value. We're not going to change it at all. You can say your reference is constant, and that's going to say you're not going to change the value. In order to do that, though, all of your methods that don't change things need to be marked as constant. So like get, we could say, is a constant method here. I think we just say const right there. So it means you only have access to the constant methods if you're passing something or declaring it as a constant. So it takes a little bit more work up front, but it could be nice on a little bit of protection. So it's a good habit to get into. Again, we're just getting into classes, so I'm not really too particular looking for stuff like that. So I wouldn't worry too much about it. We can come back to that when we get back into classes again in the other chapter. Yep. You can have a function return objects. Sure, we could do that sort of thing. Object composition, that's a fun one. So when one class is made up of another class or contains another class, here is a fun example. So let's make a new class. Right, we can do that. And let's call this one, how about student? So I have a class for student, right? And student has a public section and a private section. So private information about student, we probably have a string for name, so we're going to need to include string. And you probably have a double for grade percentage, right? And then in our constructor, oh no, here's another fun thing too. This is good. This is good. Lowercase s string. Nope. Why does it not like my string? It should like string. What did I do wrong? Maybe it's just confused for a minute. I swear I've used strings before. I'm not going crazy, am I? Yeah, lowercase. Okay, lowercase s. I thought it was lowercase s. Misspelled student. Oh, all right. You get some bonus points there for catching my typo. 10 bonus points, face. Oh, my namespace. Thank you. Using namespace standard. And this is why this can cause some trouble. If you don't have this using namespace standard everywhere else, it's going to bite you because it won't know what strings are when you go use this other places. I just use it everywhere and I'm not ashamed. So it just, sometimes you forget. Thanks there, Blowfish. All right, so we got a string for name and a grade. Now, name, we probably don't want to be changeable, right? Like once you make a student record for my class, right? If I'm going to be keeping track of your score, I probably don't want that to change because it's going to really confuse me. So what we can do is we can have a constructor method then that takes a string for name. And then what we do is we set this name equals the name argument. Right? So what we're essentially doing here is we're making this name a read-only variable. Like the only place it gets set is in the constructor. So I don't have a public set method for it. Right, I'll have a public get method name for it, which I can return name. So you can get the name out, but I'm not going to give you a public set. So if I don't want this variable to be mutable, if I don't want it to change, at least outside of my class, then I'm going to leave it in here. Hey, that sounds super cool. Star. Yeah, chess related would be really cool. I mean, chess is a real world problem, right? I think. So lots of totally cool stuff happening in the chess world in terms of artificial intelligence. It's a bit beyond this class, unfortunately. If you want to come chat over in the Discord, I'd be happy to talk more about that. And I've got a friend you might be interested in talking with. Oh man, I really should remember his name now. Hang on, it'll come to me. What's his name? All right, I gotta look him up now. Twitch. JJ, that's what it is. JJ Chess, isn't it? Oh man, okay, I can look him up. Oh, that's right. Samurai. Last 7 Samurai. Samurai. I think I can spell right. Maybe. So he's a Turkish grandmaster, and he's studying computer engineering, something like that, over in St. Louis, where they've got a really good chess hub or chess club. I think that's his Twitch, right? We'll see if it loads. Maybe. I don't know why everything is so slow. I blame it will be Visual Studios, I'm sure, is a hog too. No? Shoot. Oh, unless I've got a time machine that's unavailable? Did he delete his channel? Oh. Maybe he deleted his channel. That's weird. Alright, maybe it's harder to get a hold of him than I thought. But he used to stream. Alright, anyway. So this, if we don't give a public set method, sort of makes the property like a read-only or a mutable property. Which is really cool. So if you don't want that to change, that's fantastic. And then I'll set my grade percentage to 0 unless I know otherwise. Right, and then I'll probably have public gets and sets. A void for get grade. I'm sorry, that should be a double for get grade percentage. And we'll return the grade percentage. And then we'll have a void method for setting that. Set grade percentage, and that'll take a double for percentage. Or I don't know, we'll call it grade percentage. And like this grade percentage is equal to the grade percentage argument. And using the this to make sure I get my instance variable here. And we've probably, right, because we have a function, we might as well call it. Set it to 0. And we might want a sanity check as well, right? So if grade percentage is greater than or equal to 0, and grade percentage is less than or equal to 100, right? We'll take that. Otherwise, maybe we'll stick you at 0, right? So somewhere between 0 and 100, inclusive of either end, is okay. Doing some of this logical operating, right? This is in bounds here. I'll take it. Otherwise, you're stuck at 0. Okay? How's that for student? You okay so far? Oh, I should have written some tests. Oh well, that's all right. We could do that another time. Now what we're going to do is we're going to use this class in another class. And we're going to call this one, I don't know, gradebook. Class gradebook. This has a public section and a private section. And we'll probably using namespace standard, and we'll probably include string because I need like a name for my class. This is a string for class name. So we'll probably make a gradebook constructor, again, that takes a string for class name. I don't want this thing to change, and we'll have this class name equal the class name. And you give me a class. Whoa. That was neat. I don't even know what it was doing there. I like got a ton of code all of a sudden. Just popped up there. Alright, so we got a class name, and then we probably now have, and again, we haven't done arrays or vectors yet. We'll do that next week. But I might have student, first student, a student, second student, and on and on and on, right? Oh, but it doesn't know what student is, so let's include student. Include student. Nope, 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 nope. Not the brace, so that's why student, with the quotes here, because it's another H file here. Oh, so now it's yelling at me because I can't make students. So if the student class doesn't have a default constructor, I can't have a student here without calling that constructor. Right, so I'm going to need a string for first student name, and maybe a string for second student name. And I can call first student equals student. Now this syntax might look a little funny. We're going to give it the first student name, this one. So we're declaring the variable and then we're assigning it here. So we're going to assign it this constructor. Right, because that way it's a class level variable that I'll have access to. PCH.h, I think that's some of the built-in stuff if you're using Windows. It's not anything I have a lot of familiarity with. Yeah, I think PCH. Let's see if we get any hits. We might not. Aha! Stack Overflow. Thank you. Pre-compiled header for console-based applications. Compile option, YU. Will not compile anything before. Interesting. Interesting, interesting. Pre-compiling stuff is really neat and can speed stuff up. It's beyond anything we're going to do in this class, though. It's more advanced C++ stuff. All right, is it happy? Uh-oh. No default constructor exists for class student. Yeah, I know. It's not going to let me do it. All right, that's all right. We'll take student. Let's try first student here. I think we can make this work. We're going to try it. Is it still not letting it work? Come on, that ought to do it. That ought to do it. We build. Oh, in the unit test class? Yeah, it must be for however it's just building itself. Yeah, a precompiled header. I was trying to make this error go away, and it was unhappy with me. So let's go back. We'll go back to using strings. But it's not letting me declare these variables here, which is unfortunate. So what we can do, we can go back over to student, line 12. Yeah, so that was our constructor here. I was trying to make this error go away. It says no default constructor exists for class student. So I can't have these defined as variables because it doesn't know how to make them, and it's unhappy with this assignment here. It's okay. We can come over to student and we can add a default constructor. And you know, a lot of times default constructors are nice, and we're just going to call our other constructor with an empty string. So student, no, student, curly braces. So if you don't give me a name, maybe I have a no name. That's not really ideal, is it? That's all right. I don't think we're going to use it. Let's try this. I think this will work. Okay, so now gradebook, and then things we can do with gradebook. Right, some other public methods. Now again, we don't have an array, so this is kind of terrible. But let's imagine here we have a void set grade, and we have a double for first student grade. And a double for second student grade. Right, so we'll take first student, we'll call set grade, given the first student's grade. And we'll take the second student. Again, we'll find a much better way to do this after next chapter. But for now, we're just doing some terribleness here. And that's okay. This is bad, but we don't have arrays or vectors yet. Okay, so don't worry about it too much. And then let's see if maybe we can return some values. So we'll have a double for get first student grade. Again, terrible, but that's fine. So we're just going to return first student dot get grade percentage, and that's a function call, so it needs the parentheses. And we'll do the same thing for get second student grade. Get second student grade. Okay. Again, very contrived, terrible example here. We're just saying, can I build a class that uses other classes inside of it? Let's see what we get. So let's come back over to our source file. We have some bottles. We're done drinking with our bottles. We'll set up a gradebook. So let's make a gradebook. Oh, but it doesn't know what gradebook is. We need to include gradebook. Gradebook. Oops. And let's say this is for CIS 2252. That's the name, right? That we'll call that constructor. Gradebook. Didn't I call it gradebook? Gradebook. Grade, capital B. It's like looking at that all funny. Gradebook. Oh, it doesn't want a string? Gradebook. Wants a string. Oh, class name, student name. That's right, 2 more names. So then let's put some students in the book. We'll put Blowfish, Fugu, and we'll put Face Sizzle in the class there. We'll give them 3 strings in a row. Right, and then we'll call gradebook dot, no, that's the wrong one. Gradebook dot set grade. Let's give Blowfish, say, a 95, and we'll give Face, say, a 97. Then we can see out. Scores in the gradebook are gradebook dot get first student and gradebook dot get second student grade and an end line. Let's see how well that works. Oh, come on, 95's not bad, Blowfish. That's a solid A. Don't feel bad about it. 100, no more drinking, and we get 95 and 97. So we got the grades out. So my class can contain other classes, which is kind of fun. Again, having like 1 and 2 is kind of silly for this gradebook example, but that's just what we went with. It might make more sense if you actually had like a singular type here that you contained. But again, you know, it's okay. It's called composition because a client is composed of another client. Yep. So, yeah, separate files. It says using the CPP files for your classes are good. I'm sure it's a good habit. Again, there's some trade-offs and pluses and minuses, so the includes is fine. If you're not using Visual Studio, you don't get this advantage of Pragma once. You have to do the if, endef, and define, and endif functions. I think we did that last week or 2 weeks ago. Just go look it up, or if you're having trouble with it, let me know. I'm happy to help. So just some general ideas of classes themselves, what should happen inside classes, what should happen outside of classes. The copy of the current gradebook contained nested class values. It just has students, so there's no like class values. I'm not sure what you exactly mean by nested class values. Like each student then will have its own grade percentage and name inside of it. Maybe we could make this a little bit cleaner here and like do a nice little string for, I don't know, print gradebook or something silly. Gradebook string. There's a better way to do this. We just haven't learned it yet. I keep saying that all the time. I'm sorry. string. So we'll have a string to, I don't know, gradebook. And then let's say, I don't know, first for student plus first student dot get name plus well, let's add an, can we add in an endl? No, we can't add in an endl. Bummer. Let's add in like a \n. Oh no, we need score, right? Score, student name, score, plus first student dot get score, or get grade percentage, sure. I'm mixing up all the things here, that's okay. \n for a new line, and then let's add the second student, second student. That's a little better, maybe. Maybe. Here, we bumped some of those down, sorry. We got to convert that to a string. String? No, I'm sorry, that's Python. To string. Nope, to understring? To string, there we go. If it's not a string already, we can't do that string concatenation, these ugly pluses, which is still kind of bad form, but that's okay. You're going to reference information in a nested class, the class in the class. You still want to use it when necessary. No, that totally makes sense, Face. So, like, if we want to give access to do these things to student, we'd need to write a function in gradebook to do it, or have a function that like gives you access directly to that instance of student, so we don't need to rewrite all of those methods. Like, hey, find student at, find the 7th student, and then you could get a reference to student and then modify it. And next week when we talk about arrays and vectors, we'll look at ways we can do that, which is much cleaner. Trying to rewrite all those student functions inside of gradebook and say, hey, do it for the first, do it for the second, is really painful and terrible. And this is a bad example for that, and I'm feeling bad now. It's a little bit contrived. Maybe I went too fancy. We should have done something a little simpler. The book's example was like, hey, I'm giving you a carpet. It's made of a rectangle plus like the fabric, because sure, that sort of thing. But we can make this work. Source. Let's go back. So we don't want to see out that anymore. We're just going to do gradebook dot get gradebook string and an endl. Let's see if that prints any prettier. I bet it will. Oops, now it didn't build. Uh-oh. Time, that's just a warning. This one here. Oh, we didn't return it. Return gradebook. There we go. Now let's see if we can run it. Yeah, so you can return references as well. We have ways of doing that instead of returning copies. There we go, and now we see Blowfish, Fugu, and Face Sizzle have their scores. And life is pretty good. Alright. Awesome. So what should happen inside of classes, what should happen outside of classes? Like, the class itself should be nice and self-contained. We got this idea of encapsulation. I want to take all the details about myself and encapsulate them. So all of my attributes that belong to this noun, all of its data is encapsulated into the class. And when I have an instance of the class, like my first student or my second student, they get unique sets of those values, which is nice, right? They should not share a name, they should not share a score, those sorts of things. Excuse me. So that's all stuff that happens inside the class. Other things are how you interact with it, right? The public functions, whether or not they're sets and gets, and hopefully some of them are more interesting, right? Pure sets and gets are really boring in a class. It's not wrong, but it's just kind of boring that all it does is represent some data. Anything that is input and output related, we haven't gotten to files yet, We kind of skipped over that in Chapter 4, where he mentioned some files, because we'll get to files again later, and we can come back to that section. It's real quick. That should happen outside of the class itself, unless that's all that class does, is you're using it to do some file helping. Because what we want these things to do, we want them to be independent and portable. Right? And maybe this class can be used in a web application, or in a mobile application, or it's a desktop application. Right? Those sorts of portability, if you're locking yourself into using input and output, like C in and C out, you can't take that class anywhere else. So a good practice is you have sets and gets, or ways of giving data to the class itself, and then in your main method, you do all the C in, C out junk. Because if we're running a main method, we know we're going to be doing console stuff. Essentially, right? We're not going to do any GUIs till much later. Actually, I don't even think we get into that at all in this class. I think the book has some information on it, but it's been a little while since I looked at it. So we want all the C in, C out stuff, all the input-output operations to happen outside of the classes, because the classes, the only thing they should care about is their data and their their methods, right? The things that they can do and the things they know about themselves. That's where we want to keep all of that. Okay. Why don't we? It's already 8:12. So why don't we take another break? We'll pick it back up with structs. We'll take a look at some more of that. We are only like halfway through the list, or the slides here. Oh my. But that's okay. We're doing great, and some of the end bit is just kind of fluffy. So when we take another break, I'll put on some more music, and we'll come back in another 10 minutes or so. Let's see, resumes at what does that put us at? 8. Let's say 23-ish. Sound good? You guys get yourself some coffee. Private student sound, accessible outside of the class. I like it. I like it, guys.
During turbulent times, preparing for the challenges and opportunities that lie ahead can be a wise investment in your career. Earning a graduate degree from the NYU School of Professional Studies readies you for the future, enhancing your knowledge and expanding your network. On-site, online, and remote study options are available for spring. Visit sps.nyu.edu/masters07 to register for an online info session. NYU SPS. Our degrees set you apart.
Dollar Shave Club brings you the ultimate shave starter set, $5 with free shipping. You get our premium 6-blade razor, 2 razor refill cartridges, prep scrub, translucent shave butter that softens hairs and leaves your skin feeling smooth, and post-shave dew that refreshes and hydrates. It's the best $5 you'll ever spend, unless you buy some winning lottery tickets. Visit dollarshaveclub.com/Spotify. Refills ship at regular price.
Prepare to die. tell you that it's over. And I know if I come any closer, I don't need to tell you that it's over. And I know if I come any closer, this is gonna be too much for us to bear. I don't need to tell you that it's over. You can probably see it in the way I stare. And I know if I come any closer, this is gonna be too much for us to bear. I don't need to tell you that it's over. You can probably see it in the way I stare. And I know if I come any closer, this is gonna be too much for us to bear. I'm just calling to say. It's gonna be too much for us to bear. I just realized I've built walls a mile high to protect my heart, but now I'm all alone, stuck on the inside. The heart doesn't need a castle, it needs a bridge. Been too scared that I'd unravel. Brick by brick, I built these walls. Now I know that I am strong. Just watch me tear them down. I'm gonna tear them down. If it couldn't break your heart, is it really love? If it can't tear you apart, is it really love?
Hey, 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 welcome back. It's 8:23. Oh, you can't see yet. Man, really, one of these days I'd love to get one of those really cool like Stream Deck things that'll switch between scenes and do all sorts of fancy stuff, but I don't know. Maybe one of these days. Alright, I got a little snack, got some coffee. You guys good? How you feeling so far? Let's do another poll. I don't know, maybe these polls are overdone here, but I like these. Well, I'm going to ask, how's it going? We'll say bad, barely okay, solid okay, good, and great. Again, I don't know, I probably say this too many times, but I miss being able to see facial expressions and see you guys. Not enough to make you guys hop on a Zoom call and like have to make you turn on your webcams and stare at you and then complain when your webcams don't work and then have to deal with all the lag and stuff. I just not a big Zoom fan myself, but that's okay. That is okay. If you guys want, we can definitely try and hop on some Zooms later to go over other topics. We can meet. I've got office hours you guys can come to. Can hop on Zoom for that. So just let me know. Just let me know. So fill out that Twitch poll. Let me know how it's going. See what you guys are up to. Man, I don't know how to work my Outlook. That is so sad. Like, you'd think you could like drag and drop emails, but no, it doesn't. It does not do that. That's fine. All right, so take the poll. Let me know how it's going. Let's take a look. It's loading. All right, 2 people are great. 1 person is solid okay. Not bad. 3 people voted out of the... How many of you guys are even around right now? Users in chat. It says we got a bunch of people in chat, but that's okay. That's all right. Again, unless you're telling me what's going on, I've got no clue, guys. So get on the Discord, direct message me, chat in the class channel if you have questions, because other people will benefit from your questions. Text me, call me, email me. One of the several options. Just let me know. Right? I worry about you guys if I don't hear anything. I think most people have turned stuff in, so that should be okay. Let me double check that real quick. I'll log in to the class on my other laptop, so I don't show your grades all over the internet here. You guys don't want that, right? Maybe I could build out the gradebook with your actual grades. Wouldn't that be fun? No? Not fun? Okay. Blowfish doesn't mind. Maybe because he got all the bonus points. Yeah, I got some quizzes I need to grade. I think I got a lot of the quizzes in. Yeah, 3 and 4 were graded. And 5 was graded, so I didn't grade the Chapter 6 quiz yet. I've got to do that one. Cool. And then after tonight we'll have the Chapter 7 quiz, and we'll just keep going 1 quiz per chapter. And it's your incentive to read in the book, right? You guys definitely don't rely on just me saying things out loud. The book is an awesome resource as well, and what I try and give you is stuff that's not right from the book, that way you're not hearing it twice, and that sort of thing, right? You want to see examples multiple different ways, because everyone learns a little bit differently. So we'll work on that. Yeah, grades are there. Okay, I got to change the grade for Project 2, because out of 15 points we made it. 15 points. There we go. Okay, and let's take a peek here. You guys around at all in Twitch chat? Anybody? Yeah, a couple of people are doing really well. A couple of people are doing very badly. But the majority, I think, are doing very well. Can I see like a stats on that? Hey, thanks for saying hi. View statistics. There we go. Yes. All right. The 19 people here. Hey, thanks for saying hi, guys. I miss you guys. Let's see. The max grade is 99.49 currently. The average grade is only 75.13. But that's because there's a couple people down at the like less than 25% range. Most people are sitting around a solid 95 to 100. We got 63% of you there to solid A. So that's a pretty good sign. A couple people in the A- range, and a couple people in the B+1, and the B+1 in the A- range. And then a couple people who I think missed turning in a project or some quizzes or something. So I think most of you are doing pretty well. So that's good. That is good to hear. But yeah, please reach out. I'd love to talk to you guys. Talk to you fine folks. I'm working on my language here. It's something to work at for sure. Okay, so let's get back into our classes. Right, so we were looking at composition, where one class can have another class inside of it. So these are classes that we wrote here, and we can pass them by reference, pass them by value, depending on what we were doing here with our model. Another type that you can use in C++, excuse me, that's similar to a class is something called a struct. And structs are kind of fun as well. So let's add a new header file. Let's call this one a assignment. So we say struct assignment. And R, struct, there we go. There we go. Oh dear. Oh, okay, PayPal alerts, that's fine. So a struct is very similar to a class. A couple different things about structs. Their fields, right? All the things here are default public instead of being default private. And typically what we do with structs is we're just a list of properties. So we don't have get methods, we don't have set methods. It's a way of grouping values together, and that's it. You can do some other fancier stuff with them here for sure, but a lot of times we just use them, for storing sets of data, right? Collection of related data. All right, so let's see. Yep. Okay, cool. So let's make this assignment. So the assignment has we got to do include string and using namespace, standard name space standard. Hey, how you doing, JJ? We were just looking for you. I think I probably found your wrong channel. Someone was working on a senior project. The Last 7 Samurai. I forgot the. I'm dumb here. Yeah, he said he's working on some AI-related project for his senior thesis or something. And I said, I know a good person, because he wanted it to be chess-related. So we're just doing some boring old C++ here. I'm sorry, folks. Not boring at all. We're doing a Let's Learn C++ class. So glad to have you along. It's interesting. C++ is pretty cool, for sure. So we're talking about structs. So a struct is similar to a class. Most of our things are public. So a lot of times they'll even leave out that public declaration here. Because the default is public. So maybe I'll just comment that out. Right? It is public by default. So we might say I've got a string for name. And maybe we have an int for possible points. And an int for earned points. Here. So I can have an assignment here, and I don't bother with gets and sets. We just go access these values directly, which is a little bit fun. So now I can say back in here, let's go include my struct with quotes. Struct. Nope. No, that was called assignment. Assignment is a struct. Include assignment H. There we go. Sometimes the type ahead is just not fantastic. So let's make an assignment. So let's see out, enter the name of an assignment. And then we'll have a string for assignment name. And we can see an assignment name. And maybe this should have spaces in it, right? Because if we don't use getLine, we can't have spaces, but that's okay. So maybe we'll just leave it out. Consider getLine. Handle spaces. Right, and then we can see out, enter the total possible points. And we could have an int for possible points. And we can see in our possible points. And then we'll have, again, we'll do this for earned points. I'll just copy paste and change a couple things. Earned points. The points earned. Okay, then we're going to make an assignment. So we're going to say assignment. I don't know, assignment. Sure, something like that. And we can set some values. So we can either use this initialization list, or we can do it the long way. Both are perfectly fine. So let's look at doing it. This is the long way, or the usual way. So we'll make an assignment, and I'll say assignment dot name is the assignment name. Oops, assignment name. And assignment dot the possible points is the possible points. And assignment dot earned points is the earned points. We could do it like that, right? The other way, this is the short way, is we say assignment, I don't know, other assignment is equal to, and then you use curly braces. And I don't know why we use curly braces. Someone came up with this and they said it's awesome. And what you have to do is you give it the elements in order. So I'm going to give it a string, I'm going to give it the name, the possible points, and the earned points. And you have to remember the order, which is really annoying. So we give it the name, give it the possible points, and we give it the earned points. Okay, and then let's write a function here, because I don't want to have to do this more than once. So let's write a print assignment function that takes an assignment. And we're going to see out all that information, right? We'll see out the name is the assignment.name. I don't know, maybe an end line? Sure, we'll just do all these on separate couts. Possible points. Assignment.possible points, and end line, and cout earned points, assignment.earned points. Right, and we just pass in an assignment. So let's print these out. So we're going to call print assignment. We're going to print the first assignment, and then we'll call print assignment, and we'll print the other assignment. Maybe. There it goes. Let's give that a shot. So they should be identical. Right? There's just two different ways of constructing them. Is it running? Come on, run. Didn't I click run? Nope, so you're not even allowed to give default values for structs. It's a little weird. All right, so this is, I don't know, project 2 for 15 possible points, and maybe we earned 10. Yep, so I think if we just forget this line, what do we get here? Let's leave that off for a second. Let's try it. I think we get garbage, which is frustrating. All right, let's try it. Yeah, so if you don't set it, you get garbage. There's no default there. That's annoying. You can add a constructor if you want to your struct. Sure, maybe that's how we're going to do our deal with it having defaults. I don't think. Yep, same thing. We can do constants. That's fine. We can return structs. We can create them. That's all fine. Okay. Yeah, so you can't give default values when you declare a struct. Where is it here? Making sure I'm not going crazy. Let's see. Dot. Defining. Yeah, so you can't initialize them in the constructor for sure. But we can, I'm sorry, you can't initialize them here. You can't say like name equals quote. It should have yelled at me for that. Of course it's not. That's weird. Okay. I don't know, it should have yelled at me. I don't know, I'm a little confused, but that's okay. That is alright. So we're going to add a constructor to this here for fun, and that way we can handle that. So we'll have an assignment constructor that takes a string for name, takes an int for possible points, and an int for earned points. And we'll just set them all. This name equals name. This possible points equals possible points. Uh-oh. There it goes. There it goes. And this earned points is the earned points. Okay, so now when we go to make a struct, let's take a look. Where did it go here? Now it won't let us make it like that. It lets us use this syntax. Can't use this syntax though. Right, so we need to hand it those values instead. So we're going to, you know what? Let's make another one here. Let's make a default constructor that calls assignment, and let's give it some values here. So we'll do it that way. So we'll make a default constructor for ourselves that gives some values. So again, our default constructor gives default values. And we can go change those values later. Right? We'll just do all the work here. Okay, now that'll be happy with us. Again, doing it the long way. And then if we forget to comment, or if we forget to set one, we won't get a garbage value. So constructors are super handy. Super handy. Structs can have other structs, right, as data inside of them. That's fine. You can have nested ones. Because everything is public, you just would get at it with like additional dots. It's crazy. No, project 2, 10 and 10. Great. That looks better. Nothing crashed. You can pass structs as arguments. Again, you can pass them by value or by reference. Defaults by value. Yeah, you can use constants, again, the same way like we could with classes. You can return them. All right, enum types is another cool thing. I don't think we need to get into any of those at the moment. We're running a little low on time. Not super low on time, but I think that's something we can read on later. I'm not planning on using enums anywhere. Interesting. Yeah, enums are cool, but that's fine. Okay, so let's move on. We'll skip over enums. You guys can read that later. To read some about enums on your own. Leave that for you guys. So object-oriented analysis and design. That's such a fancy term here in our book. So again, this idea of how we are designing our code, designing our project to solve a problem. Because if our code isn't solving problems, it's really worthless. And you know, not all the time the problem that we're solving for class is super interesting, but hey, like project 2, we're doing this little simulator. That's the problem we're trying to solve. So we need to look at it in this object-oriented manner. When you start identifying what are your classes and objects, what are their attributes, what are their behaviors, how do classes relate to each other, that's all about object-oriented analysis and design. What you want to do is you want to pick out your nouns, right? Usually anything that is a noun could be a class. Doesn't mean it has to be. And you could certainly go crazy and make way too many classes. And, you know, it's not going to be anything terrible, but it's going to be more work at that point. We want to find the right balance. And coding is all an art. There's definitely some science to it, and there's some very particular things that we can do to increase performance. That's very science-based. But the art is designing, and how do we approach a solution and try and get this concept into step-by-step instructions into the computer. That's all art. So looking at anything that's a noun as a potential class, that's an option. Right? And then we can start looking at those classes and say, well, what data does that class have? What does it know about itself? What are its attributes? And then what things does it need to do? Right? So the ways that you interact with that class could be its public methods, public functions. You start designing that way. Those are behaviors, right? Things that they do, and then relationships between the classes. So what does one class do with another class? There's like an access relationship or a uses relationship. So like our class uses a bottle because we're going to drink the bottle. And again, that's not super interesting or anything. Or the composition type relationship, where our gradebook has a student because it's composed of a bunch of student records. And then we haven't gotten to it yet, but there's another relationship called inheritance, which is a relationship. We'll get more once we get into the next object-oriented chapter. But again, don't worry too much about that right now. So try and find all the nouns, find all the things that you do with them, find the data that you need, figure out what classes are responsible for what. Again, usually you want all of your user input and output to happen outside of classes. Our class's job should be to do all that business logic sort of stuff, like, hey, this is the data, this is the way we interact with it for this noun. Right? Deal with all the input and output later in your main, or write other functions inside of your main method class here, your main code, to do that sort of stuff. Right? You can take advantage of functions for sure. Definitely good to do. The object reuse is ideal, but again, I think that's maybe an overreaching ideal, especially at this level. We're probably not going to ever reuse any of these classes we do in class. But you sort of want it designed for reuse in mind, so that maybe later on I can reuse it. That's great. Yeah, the goal is to support reuse, but not necessarily, that's not always the first reason that we want to build classes out. So yeah, object-based versus object-oriented. Yeah, if you have classes and objects, you're object-based. This is kind of a silly distinction here, but you're object-oriented, that you know what the relationship between classes are, you create classes from other classes, you have member functions, the behaviors based on the object itself, or the class itself. That's more object-oriented. Right? We can do all these things and like have objects and be object-based without necessarily being object-oriented, where we've kind of designed that solution in mind. And then there's a little bit in the chapter about doing some graphical stuff only in Windows. So we're just going to skip it because not everyone's on Windows. And again, it's not anything we necessarily need to do right now. It's just got a quick little couple slides on it there, one little section in the book about it. All right, so that's it. Actually, you guys did really good. We got through the end of that. Let me commit our code here. So this is more fun with classes and structs. Come on, commit, push. Come on, commit, push. Let's go. So we've got a little bit more time to work on project 2. Ask me questions about it. Again, for unit testing, you probably want to set it up to take that seed value. That's probably going to be the easiest way to go about that, because we don't necessarily know an up or down or even changed. Most of the time, changed will work. So if you want to go that route, I won't dock you for it, because it's rare you'll get an exact 0 on that value when you're doing random. But again, up to you guys. Next week we'll pick up arrays and vectors, start talking about the third project, or project 3, which is the 4th project. Once we talk about arrays and vectors, you'll understand why this was called project 0. It's a programming, I guess joke is the wrong word for it, but that's okay. So we'll do arrays and vectors. This will let us do even more with what we've been learning, which is fantastic. And then we're going to skip 9 and go to pointers here in 10, and then we'll pick up some review for the midterm there as well this week. And then the week of Halloween, the 28th, we'll have the midterm available. It'll be just like the other quizzes available in D2L, but this one will have a time limit on it. We'll have more details when we get closer. I'll give you some example problems, that sort of thing. And to discourage you guys from engaging in any sort of academic dishonesty where you might want to take the test together, I unfortunately have to write a really large test bank to ensure you all get a random set of questions. Ugh. Part of me is tempted to get the book's test bank, but I just hate their questions that they write. And really, I'd rather ask you questions like, hey, write a little snippet of code that does this. Not anything big like an entire project, but like, hey, write me a loop that does this, or write a function that does this, or write a, maybe a small class with some sets and gets. Not going to do anything super interesting, or super complex, sorry. So it'll be up through arrays and vectors and pointers, and then we'll pick up chapter 11, do more about classes, object-oriented programming. We'll skip 12, and we'll get to all file I/O stuff. So we're going to pick up the little bit of file I/O we left out of chapter 5 from looping, and then we'll do the advanced I/O stuff. We'll get into recursion, polymorphism, and virtual functions, some additional classes, object-oriented stuff, which is cool. Polymorphism is another foundation of object-oriented programming. And we'll talk about the final project at that point, and then we'll have Thanksgiving break, pick up exceptions and templates. I should make that bigger, I'm sorry, it's kind of small. Exceptions and templates, the standard template library, chapter 17, and then the last week of class that would have been the final exam. I've got all 4 hours set aside for you guys to do any last-minute touches on your final project. Again, if this would have been an in-person class, I would have had you guys work in pairs. It's really a good experience to work with someone else in your professional development career. I really hope you're not stuck working by yourself the entire time. It's really boring and really lonely. And honestly, working with another person is going to increase the quality of your application or whatever you're writing, or your program, because it really is true. 2 heads are better than 1, because you can hopefully find what isn't going to work right as you're designing that solution much faster. Right? And they've got ideas of things to test and check, and you've got ideas of things to test and check. And it's definitely well worth it to learn to work with people. And Git is pretty good at it. Turns out that's what it's made for, the source control. I mean, it's fantastic for single-person source control, but it's designed for team collaboration. So I'll show you a couple more tips for that. If you guys want to work in pairs, feel free to reach out to your neighbor, find someone in Discord who's actually in the class. You might want to ask people like if they're actually in the class or not, if they want to help. No pulling in any ringers. It's got to be someone else in the class to be your partner, and we can work on that. And we are through, so we're officially a third of the way through. We missed last week, so this is really like our week 5. 5 out of 15 weeks, a third of the way through. Hopefully it's going well, or at least okay for you guys. And please reach out. Let me know if you're having trouble. If you have questions with things, like I really want to answer your questions. Again, have some sort of like you've tried to work through it yourself for at least half an hour, maybe an hour. But after that, banging your head against the keyboard is not going to help any better. And really, I'm here to help you learn it. I don't like calling my role as a teacher. I'm not really teaching you guys. What I'm doing is I'm helping you learn. I think that way of looking at it is much better for what I'm trying to do for you guys. Right? You've got all this material. I'm giving you examples. I'm helping you learn it here and helping you practice it and get better at it and develop your skills. So, all right, it's been fun. If you guys don't have anything else, we can call it a night. Again, if this were in person and we had computers in front of us, we would now go and try some of these things, and I'd give you a little exercise to try. Like write a little class that does something. Teaching us to teach ourselves. Yeah, I mean, look up documentation, man. Documentation. There's all sorts of good resources for sure. So, yeah, my goal is to pull out the highlights, show you the good stuff. Hopefully you're reading the book. For sure, the book is super helpful. Got a lot of resources in there, a lot of examples for you guys. And maybe for the final project, we'll set up one of these pipelines. It wasn't so bad. Oh, I wanted to show you what it was that fixed it. Oops. Push. Let me go to my history here and see where it fixed it. Yes, this one here. There was this one, it generated this YAML file for me, and I had to change the build platform and configuration there, not in the dropdown when I was editing the pipeline. Like if I was edit pipeline, I tried to change it in the variables, because that's what I thought the instruction said, was to add a variable for it. That's not what the instructions meant. They didn't mean change the variables. They meant change the YAML. YAML is such a funny file. YML. I guess it's not YAML, it's just YML. YAML is something else, isn't it? YAML. Maybe it'll load here. Yeah, so I was supposed to change it here in the variables section not in the variables button. Oh, you want a dad joke? Yes, you got it. You got it. I just got a pretty good one here. Where is it? Where is it? Where is it? Oh yeah, so we were out in Philly for my daughter's surgery the other week, and when we got back, I realized I had lost my key or forgotten to take the house key, and we locked the house up. So I had to call a locksmith to come and open the door for me. And I get him on the phone. I say, hey, I'm locked out of my house. Can you come by? He says, oh, no, don't worry about it. All you have to do is talk really calmly to your lock, because communication is key. Needless to say, I called a different locksmith. All right, here's a bonus one. Why couldn't the green pepper practice archery? Because it didn't habanero. Oh, that one might be funnier as a picture. Poor little sad green pepper, missing his arrow. Let's see. You want one more? Another bonus one? Let me see, I got it here. Got it. So, you know, my littlest guy, he really loves Sesame Street. Oh, thank you, Anonymous Kitty. Yeah, he really loves Sesame Street. So I like Sesame Street's always to the front of my mind. And as we're getting ready for Halloween and preparing, my other kid asked me, who's my favorite vampire? And I said, oh, you know, the guy on Sesame, the Muppet on Sesame Street. And my son looked at me, he's like, no, that doesn't count. He doesn't count. And I said, oh no, I assure you, he does. You know, Count Von Count, from Sesame Street. Maybe you guys don't watch that hours and hours a day like my little guy does. Come on, that was a good one, right? I liked that one. All right. Awesome. I think we are all set then. Again, you know, hang out, ask questions, practice some stuff, try things, work on the project. Let me know where you get stuck, and we can go from there. Yeah. Add these variables for platform and debug instead of these variables over here. Who knew, right? So now I know, and it's easy enough. You copy paste the stuff and it works. So we can build our own little continuous testing later, which is fun. So that's a fun thing. All right, again, sorry for the mix-up with Project 2 and missing you guys last week. Hopefully no one's upset with me that I pushed the deadline out. If you got it in on time and you really want a bonus point because you did some heroics and sacrificed a bunch of stuff to get it in on time, let me know. I'm flexible there. But other than that, I've got the rubric out there now. We should be good. I'll be loading up the Chapter 7 quiz shortly, and you guys can take that. And we'll be good to keep going. So I am going back to Philly in November. Probably these couple weeks here. I will definitely plan much better ahead and have some recorded videos for you guys. I'll miss being live, but the Wi-Fi wasn't really stable enough for me to try it. So my daughter's got her actual spinal fusion surgery then. She's just staying there for 6 weeks with the Halo traction. So I'll definitely plan better and make sure I've got this content ready for you guys to go. And then I can be around on chat easy enough, answering questions or doing some screen shares if you guys need to. And we can go from there. Okay? Awesome. You guys take care. Oh, let me see. Is there anyone who's on Twitch right now that we want to go hang out and raid? I don't know. I recently found out it's bad form to keep raiding the exact same people over and over and over and over again. Did I take you over to the Chess Bros last time? Chess Bros? They're fun. I don't know if I can raid their channel or not, but it's definitely an adult channel though, but that's okay. Yeah, we'll go do that, and then I'll just hang out in the Discord and we can go from there. Alright, awesome. We can go watch some chess. Where do they go? Yeah. Alright, so we're going to head out that way. You guys take care. Shoot me your questions. Keep in touch. Let me know what I can do for you guys, okay? It's been fun.